Hello everyone, GM. I can see people are getting in. I will leave 20 seconds that people keep tuning in. I see some questions in Discord. Otherwise, everyone, welcome to the second workshop of the EulerSwap Builder competition. Many of you has been very excited about what to be thought in this session. So today we have a special guest, one of the co-founders of the Euler, Doug, going to be sharing technical deep dive of the EulerSwap and also what kind of things you can build and go through different details. Yes, I can see people dropping GM. So everyone also try to drop GM or be active during the session, because obviously our speakers cannot see your face due to the nice streaming quality. But if you have engaging questions or having some nice comments about what feature you like, this is going to help us a lot. So now, without further ado, let me invite our speakers to the stage. Someone is joining in midnight. I can see. Community, because all of you are based somewhere else. I'm personally based in Munich. Doug, where are you located now?
Hi there. I'm based in Toronto, Canada.
Yeah, and then I can see perhaps midnight ones must be based in Asia. So we have every hackers from everywhere, and now we're gonna have very exciting session today. So Doug, thank you for joining us, and please, floor is yours.
Okay, thank you very much. Yeah, and thanks everyone for coming and all the crazy time zones around the world too. Yeah, so I'm Doug Hoyte, one of the co-founders of Euler, but I think most of you probably saw Michael's introduction about EulerSwap, so you probably have a familiar, you're familiar with the high level concept. And what I wanted to do today was just give a little bit of a more of an overview of the technical things. So let me share my screen quickly. Yeah, essentially what I wanted to do today was basically three things: is give a little bit of a motivation for why EulerSwap is built the way it is, what problems it's solving, and how we envision people using it, including a little special custom UI that this is kind of going to be the first public sneak peek of it ever. So you're all lucky, but it's very in beta. We'll get there. And then the second thing I wanted to do was just do a little bit of a code walkthrough of some of the more interesting and important bits, especially if you're planning on integrating EulerSwap. And then finally open the floor to questions from builders or anyone else curious about how it works or whatever. Yeah, so as you all know, EulerSwap is a way to leverage the lending functionality of the Euler platform to provide swaps, to facilitate swaps. And what we did about just over a week ago was we did this contest called Capture the Flag. And the idea was that the Euler DAO put some money into an account and enabled EulerSwap in a couple configurations and said, go ahead and try to hack it. And if you are able to hack it, you get the money, right? So fortunately, no one did. But what I'm showing you now is our account that we actually set this up with, right? There's a not too commonly known feature of the Euler UI called spy mode, but you can paste in an account and spy and look at it's at the interface from the perspective of this account. So this is what we did. We deposited $250,000 of USDC into subaccount 0. That's this one. And then another 250,000 in subaccount 1. Oops, sorry, I clicked into the position. Didn't mean to do that. And then so both of them had 250,000 USDCs. And then we set up EulerSwap operators on each one. And one of them was making a market in USDC USDT, and the other one was in USDC WETH, right? So the really interesting thing that I think about EulerSwap is that when you put your money into EulerSwap, it's not locked up, for example, in a Uniswap pool. It's not in some other contract and locked over there. No, it's still in your account, right? And so you're still earning interest on things, and obviously paying interest on any debts. sorry, like I'm earning interest on deposits, paying interest on debts, right? So if you hover over this, you can see that this particular position, we're actually earning 3.25% on the interest, right? And that's net of the borrows, right? And then on top of that, we are also earning some rewards, the rewards API. And yeah, I see in the chat the 35 oil tokens that we've already earned. So that was just in the last week from this. So, but it's interesting because, you know, if you did want to mine rewards on some pair, you can do that with the exact same strategy you would use otherwise, and enable an EulerSwap operator to potentially get extra yield, right? So you can see that, yeah, right now both these accounts are profitable. There was a like slight suboptimality that caused that caused the USDT one to earn a little bit less than it should, but as you can see, it's already made up that and is still profitable. So we've learned a little bit from this, and we've been experimenting on it. So why don't I just click into the USDT position to show you just a little bit more detail about how it's set up here. Is this we deposited 250,000, yes, but then markets actually performed trading on our account, right? So what they did was they actually borrowed USDT and swapped it into USDC. So we're actually carrying this leveraged position, right? As you can see, this is our loan to value ratio, right? So on that $250,000 deposit, we actually have 650,000 USDC deposited and 400,000 USDT borrowed, right? And then if you hover over here, you can see this is we're earning this percent on the supply, and we're paying this percent on the borrow, right? However, note that the supply is bigger than the borrow, so it actually nets out that our total return on our equity is still positive, right? So so that's pretty cool. And as like I said, we're earning Euler rewards, right? And this one is pretty great because there's not much price risk, right? Like USDT, USDC, they're both stable pegged assets, so they shouldn't fluctuate too much, right? If we go into the USDC WETH one, it's a little bit of a different story because, as we all know, Ether price goes up and down, and that gives it so that there's a bit of a risk of impermanent loss, right? And that's basically like, you know, if the pool is selling any asset, then probably you're going to get people are going to load up the one that's going down in price on you, right? So it's pretty important to manage these types of pools and like watch them and rebalance them and so on. But yes, exactly correct. The observation is just like you would on Uniswap, you still have this issue of impermanent loss. Yeah. Oh, and then Chris's question just previously about how a user wants to provide liquidity. Excellent question. This is and this is kind of the neat thing too, is that you can use our regular UI, right? To if you wanted to set up a EulerSwap instance, the very first thing you do is go to our UI and deposit exactly as you normally would, right? And that way you have like you know, multi-sig safe account support, you have permit to, you have all these features, batch support, the built-in swaps that we have so that you can automatically set up or leverage and deleverage a position. So all the features we have in the UI work great combined with EulerSwap, right? But anyway, but that's just for providing the initial liquidity. Next, of course, you need to actually set up your EulerSwap instance, right? And this is what I wanted to show you next, is this little utility I have right here called Maglev. And this is, like I said, this is kind of the first public sneak peek of this UI. and this is very much an work in progress beta thing. So bear with me here. But if right now this is connected to mainnet by default, it's Ethereum up here. So we'll get to the little bit of the specifics in a minute, Andrew. Let me carry on with the UI here. This UI is basically like a kind of admin console for configuring EulerSwap and also for testing and so on, right? So you can see here in the swap tab, it lists all the different operators, all the different EulerSwap instances that have been created, right? And on mainnet, right? That are currently active, right? And those are, like I said, just our two test ones here for the capture the flag. So you see that you have a USDC and a WETH and a USDC and USDT, right? And if you did want to test them, this swap form actually does work, right? If you did want to actually execute a swap and convert one of these tokens to another one, you can. Or the swap is not usually designed to be operated like this. Instead, it's like solvers and so on are supposed to do it magically in the background. But this is a testing situation, like a testing interface that you can test pools, for example. So here I'm getting a quote. If I want to do USDC turn 1 into USDT, converting 1 USDC into how much USDT? This much USDT, right? This is the quote I'm getting, right? And then if you do 10 instead, you get just a little less than 10, 100, a little less than 100. Notice that as it gets bigger and bigger, that price impact is going to grow up larger and larger, right? So, especially if I go, well, this much is just cannot be satisfied by that pool. That's a $10 million swap. But $1 million swap can be implemented, right? Which is the really cool thing, because remember, we only put $250,000 into this pool. The NAV, the net asset value of our account, is just a little bit more than 250,000 now. But I can still service a swap with not too bad price impact of $1 million, right? And obviously, this is just a regular swap form. You can flip it around. Now I'm going USDT to USDC. It's nearly symmetric. There's also exact in or exact out. So that's that. But the sort of interesting thing is that I'm just going to reload this to reset the form. There's these links to these different instances. So if I click on the USDC USDT one, this is sort of a graphical representation of the account and also the curve, right? I definitely want to add some more labels and things to make this more intuitive. But for example, you can hover over the little bars to get a little bit more information. First thing I want to show is this purple is your NAV, right? That's your net asset value. This is actually like what you essentially would have if you liquidated your position right now and withdrew everything. This would be what you have, your net asset value, right? However, notice that we also have these other bars, right? And what these represent is the amount that the additional amount that you've supplied and borrowed, right? So this is the red portion represents our debt of USDT, because if you go back to here, this is the wrong position. But if you go to this one, you'll see that we have a debt of about just shy of 400,000 USDT, and that's what we see here too, right? 400,000 USDT. And then, of course, to pay back that, you would have to, de-loop yourself, right? You, in other words, have to swap some of this USDC that you have and use it to repay, right? That's the light purple, right? And that would leave you with your NAV. The green line is the NAV midpoint, and that's kind of the thing that is going to, you should sort of center yourself around when you think about how you move along the curve, right? It's a little bit arbitrary, but it helps the pictorial representation here. The other thing is this dashed line, which is the curve equilibrium, right? And that's a little bit of an arbitrary point too, but it's kind of like the place on the curve where the price impact it bottoms out, I guess you could say, right? And I'll show that a little bit more on the configurator screen as opposed to the view. But you can see here, this other large line represents the actual EulerSwap curve itself, right? So as you get to the equilibrium, or like when you're at the equilibrium, it's right at the equilibrium price that you've set, which in this case we hard coded to 1, right? Which is not maybe it's not necessarily the actual market price of this pair, right? And the reason why this is not centered at the equilibrium is because of that. Is because the actual market price of USDC USDT is not 1. It's slightly below, right? It's 0.9996, right? Arbitrage forces it to be here, right? If it was anywhere other than here, arbitrage would push it to this location, right? So, this is arguably the equilibrium could have been set here, and then that way we wouldn't have this leverage position. But it's sort of a nice test that it was, because now we see, like, the effects of having this position proves the concept. But anyway, as you can see, the more you move away from the equilibrium, the larger the price impact, right? So that means that, this area, the white area, is all pretty flat, right? The price impact is all like less than 1%, right? It's only when you start to get into the red area that the price impact really, really jumps up. So that means that the green line could float all in this white area without too much impact. It's a very flat, or also called concentrated region of the curve, right? And then the table down here at the bottom is just kind of like the low level, or there's like a rendition of the low level EulerSwap parameters, more or less, right? sort of interesting more bit is when you start to get to the configuration section. Here I've got it just pointed to a local blockchain foundry. So I don't actually have 10,000 Ether, right? That's just the foundry test account. But this is kind of the admin interface for if you wanted to create an EulerSwap, right? And again, this is very much a work in progress, so there's definitely bugs, but it does work. You can do the same thing on the live one here if you connect to mainnet or Unichain. But I'm just going to do the Foundry one here just to demonstrate. So the first thing you do is, you have these different sub accounts. In this case, I've seeded account 0 with, relatively significant amount of money, and I've already set up a position to a borrow. There's a USDT borrow, and that results in about 3.27 times leverage on this account. So interesting bit. If I click this new, this new thing in the EulerSwap section here, then I can choose which assets I would like to create my EulerSwap curve on. For simplicity, let's just do USDT, USDC. Yeah, and by the way, you're also choosing the vaults here, right? That's this is the asset, this is the special ID of the vault, and this is the product from that is part of, right? Like that would usually be like Euler Prime or something like this, right? That's how you can distinguish between the different USDC vaults. So anyway, once you've chosen your vaults, you hit configure, and you get to this configurator screen, okay? And this is where it starts to get a little bit interesting. So let me just like rehash what I explained earlier, is that the further this green line moves to the right, the more USDC deposits you're going to have, and the more USDT debt you're going to have, right? The red line will grow too. The red bar will grow too. Red bar is always equal to the light purple bar. They're always the same, just flipped over on. So if I did move further, like I increased my leverage, like I did, borrowed more USDT and turned it into USDC, this thing would move further and further this way, right, along the curve, right? And you can actually see this this green line represents what the price is on the curve at that point, the marginal price of the curve, okay? So in this case, I've set the equilibrium point, which is that sort of like arbitrary point where the price impacts like flatten out and start to get like, better in one direction and worse, and like better in one direction either side, right? That I've arbitrarily set to this condition where we have totally deleveraged and we have exactly equal USDC and USDT deposits, and there's no debt, right? That's what would happen if this thing bottomed out all the way here and the green line was right at the middle, right? But sometimes you might not want to do that, right? Sometimes you might want to put the equilibrium right at your starting point, right? In this case, this would probably be typical in that if you install this, you would have no loss to arbitrage, right? Assuming that this price is the correct market price, which, by the way, this is taken from a pricing API, so it should be, and you can hit refresh to get the new one. But yeah, in this case, if I install this right now, I would not lose anything to arbitrage, like I said, because the marginal price of the curve is equal to what we believe the market price to be, right? However, if I set it to here, like, it doesn't matter anywhere really, but in the middle, for example, then the market price would be very, very far off of where the equilibrium price is. So I would expect to lose a lot to arbitrage, right? So you have to be a little bit careful. So probably I should make the default so it sits there, right? That would actually make more sense. The other thing to notice is that the question in the chat is this a neat environment for doing local tests? Is it available publicly? The interface itself is available here, but the Foundry needs a little bit of setup. We have like a private repo that sets up the Foundry for you and installs the vaults and stuff. That's not public, but actually, I think we could make it public. There's no reason. I'll follow up on that and let you know. And another question, vaults are tied to each pool or across pools? Every pool has 2 vaults, and it cannot be changed, right? So if you did want to use different vaults, you'd have to uninstall this pool and create a new one. Yeah, so they're statically linked. Each pool is linked to 2 vaults. So yeah, the other thing I wanted to point out is that this green line can go all the way up to here, according to this curve, right? Because this curve stretches all the way up here. Yeah, you wouldn't want to go there because look, it's like 99, 97% price impact, right? You'd be throwing all your money away. You'd lose everything to price impact if you traded that far. But in principle, it could, right? This white line represents the boundary, right? This is like, if you reach your green line here, you would be totally maxed out, and you would no longer be able to do any more. You wouldn't be able to go any more to the right without becoming into like violation, right? The EVK, the Euler vault contracts would not allow you to do that, right? So if you did end up here, it might be a little bit risky because you aren't that far away from being liquidated, right? So instead, you might want to like constrain your curve a little bit and drag this thing down, right? And that way, you would only go up to here in the very, very worst case, and you would still be relatively, far away from the actual liquidation point, right? And similarly, you might want to do that in this one, right? And notice that this is actually asymmetric. You could trade much, much further down here than you can like this, right? You don't have to do that. You can make it totally symmetric, right? In this particular configuration, trading will always keep you with a USDC debt, right? The green line is always going to be here in this range, which means they're always going to have at least like this amount. So you can see where I'm highlighting with my mouse here, but this amount of debt, right? So this will always keep you with a USDC, USDT leverage position, right? But you don't have to do that. You could like bring it down to here, and that way you would deleverage yourself all the way, but you would never be taking any USDC debt, right? Because it would stop. Your green line would stop here, and you wouldn't ever get any red onto the right hand side of the screen, right? Yeah, this is, I don't know. We're debating internally if this way even makes sense to represent the curves and the map it to the state of your account. But in my mind, this is what makes the most sense. The other kind of parameter is that you've probably seen like the gradient, like white color changing to red color represents roughly the price impact, right? And in this case, like you're not going to go too far before you start to get into multiple like two-digit price impacts and so on, right? That parameter, remember, can be changed by the concentration, right? So if I change this to 99%, oh well, yeah. So it's the other side. This represents the concentration from the swapper's perspective. But as you can see, if I change this to 99%, that started to get a lot more white, right? So like if I drag this all the way down, this is EulerSwap 2. It's not concentrated at all. It's just quadratic. Like it's a very, very bad price impact immediately, right? And if I drag it all the way to 100%, well, it doesn't actually do 100%. And there's a small bug. This gradient should actually pretty much just be all white. It's just just a coding glitch makes it a little more red, but you can still see it's still basically 0% price impact if I go that high, right? This would be constant sum, right? So this would be like there is no price impact, and all I want to do is treat USDC and USDT as like 1 for 1, right? Or this price, you could always shop any amount at that price, right? But typically you want to discourage people from swapping you too far to the edge of the curve, and you want to encourage people to bring you back to the equilibrium point, right? That's why you don't use a concentration like this. That's why you pick some kind of middle ground between Uniswap 2 style and like constant sum style. That's the great thing about EulerSwap, is that the curve is parameterizable, right? Is that you can pick and choose, and it's asymmetric, right? You could make one side super, super concentrated and one side pretty not concentrated at all, right? In this case, it would like strongly discourage swaps in this direction, but encourage swaps in this direction, right? It's only, you see how almost 0% price impact. I mean, like this is a bit unrealistic. You wouldn't do that. I think we for our pools we configured 99.9 on the stables, in which case you do start to get like a price impact here of like 1%. But notice that's still like several times of our NAV, right? So these are still pretty large size trades. Yeah, and there's not too much more to say than that. Then you can configure the fee, right? This is like what percent the LPs are taking out of every swap, and of course the price. You don't have to set this to market price. You could set it to arbitrary, to anything you want. It's just whatever. It's just what it's a parameter of the curve of at the equilibrium price. What should the price at equilibrium point? What should the price be? And then like at the end you can hit show raw and see like literally the actual the raw values that would get passed into the contract to create this pool. Or you can actually click install here, and probably you can't see here, but well, you can see the little MetaMask has a one icon. If I hit install, which I will, then all of a sudden now I have the pool, and if you go to swap account here, you'll see it's appeared here, right? Yeah. So there's still a lot of work to do on this UI, but it's kind of like, at least what I'm thinking at this time, we will be using to configure the pools. So yeah, any questions on the configuration? I see a couple here already. First one from Brian: does concentration adjust the assets within the position, or does it adjust the range of the position while keeping the asset quantities stable? The concentration represents like essentially how much the price is changing, right, per unit of swapping, right? It's like the slope. So it when you move along the curve, yes, by definition, your composition of assets in your account will be changing, right? Because the curve is basically controls what those proportions of assets are, right? So no, the assets are not stable. And in fact, except in the like sort of degenerate case where it's entirely concentrated, as you move a lot away from the equilibrium point, your NAV will be increasing, right? Because that's where the price impact comes from, right? Is you're taking a little bit more than the current fair market value price into your account than you're giving out, right? So in that case, that's also profit for an arbitrager, right? They actually get a good deal to swap you back to the equilibrium price, right? Yeah, so I hope that answers your question. Good question from Chris here. How does equilibrium impact to the pool price? So yeah, this is a really interesting point. Is that, for example, if I go back to the actual mainnet one here, this is our USDC USD2 pool. You can see that the current market price is not at the midpoint, right? So we set the equilibrium price to be exactly at 1, right? And like, to be perfectly honest, that was the kind of my mistake when I configured it. I should have looked up the market price, but I just figured like, whatever, it's probably close enough. But still, we had about a $350 loss when we deployed this pool. But fortunately, we've already made that up, and now we're profitable again. But yeah, so the interesting thing is, and maybe this is actually maybe you can see this even better on the WEF pool. Let me go there. Here you can see that the equilibrium price is set here, but we're not at the equilibrium on our curve, right? In fact, like if I go down directly from the green onto this and look at the curve here, this should be the current market price of WEF, like of Ether, right? 2735, which I think is, I'm just checking another window. It's pretty close. Yeah, 2738 I see on CoinMarketCap. So if the market is functioning correctly, this will track the market price, right? Along, like you see on my hover, that WEF USDC, this will track the market price, right? So when we installed it, the curve market price, like the current price of Ether was about this, 2625 or 27 or something like this, right? So at that point, we had no arbitrage loss because we did correctly set the market price at the equilibrium price, and so there's no trading, there was no arbitrage opportunity until like the market started to move, right? In which case, it's moved over this far, right? And this is where our impermanent losses come from too, right? Yeah, so the question is, yeah, the equilibrium point and the price at equilibrium is a curve parameter, right? And it will not, and where you are on the curve actually will depend on the market. The market will push you to a place on the curve, right? It's just that the equilibrium price usually would set it as like where you want to target the curve to be in the typical case, right? Because it's usually the place that you would have the least amount of trading loss from the swapper's perspective. And it is arbitrary though. And in fact, one thing you can do is you can actually set the equilibrium entirely at the right or entirely at the left of the curve. And that will, basically kind of, if you set the market price there as well, enforce like one-way swapping, right? Like swap in one direction and then arbitrage back, and won't support like fresh swaps in the other direction. Hope I'm explaining it well. Yes. So question from Cam, can you set equilibrium reserve and current reserve different from each other at initialization? And is there any utility in that? Very good question. Yes, you can. So so if I go to edit here, what this does is it like preloads this one I've already made in the Foundry one into the current one, so I can just reconfigure it. In this case, if I reinstall this here, notice that the current reserves and the equilibrium reserves are exactly the same, right, on both sides. So in this case, you have started at a zero arbitrage condition, right? And this is, like I said, probably the typical case, assuming that you've set this to be the correct market price. Now the question is, if there's ever any utility of not doing that, of actually installing a pool like this, right? Like unfortunately, in this case, you would expect to lose like a good deal to arbitrage loss, right? Because the fair market price is set here, right? Like assuming that we do set this to the fair market price. So why would you do that? Usually you wouldn't, but in some cases you might, right? And the question is like, and the distinction is that this top bar is kind of the state of my account right now, right? And this curve is like kind of an abstract geometrical shape I'm putting on top of the curve to encourage the movement of the real life curve, the real life balances along this curve, right? So imagine that I am in this position, right? How do I, and I want to be here, right? How do I get there? Well, I have to do a swap, right? I have to go back into the Euler UI and deleverage myself, right? I mean, we can just do it in simulation here, right? This is in SPY mode. I'm in, well, better one to look at the WEF one. If I just go here, I can deleverage myself. Sorry, it's a little bit slow, but I did click it, didn't I? Okay, here we go. So I could do that, right? I can go repay this WEF, and I'm going to swap collateral, and I'm going to say, I don't know, I'm going to do, 75% of this, right? Accept. And then Euler will fetch you a quote and actually give you a swapping, right? Now, the interesting thing is that, look here, when I do the swap, there's going to be a non-zero price impact, right? And I'll probably have to have some slippage protection and stuff too. Yeah, okay, it's just getting a quote. But when it does, there will be a non-zero price impact, right? So going back to here, the configurator is, I can either pay that price impact in the UI, or I could have like outsource that to the market, right? I could figure out an appropriate concentration. Let's just say 99.9. And then here, right, this would be a 0.1 price impact approximately that I would pay for this to happen, right? And let's see what I'm paying here. So 0.04. Okay. So I could change the concentration to match that or whatever, right? But anyway, the point is that yes, there might be some cases where you actually do want to do this, right? To actually set them separately, right? And also notice that you could compute a different price here, such that the market price does not have any arbitrage loss, but you still parameterize the curve as this being like the inflection point of the curve, I guess. I don't know if that's the right math term, but yeah, I guess like equilibrium is sort of just like it's just sort of like an arbitrary detail of the curve. You have to put somewhere, right? We have these two kind of like connected geometrical shapes, and they have to be joined somewhere, right? So whether that matches up to the market price or where your current account state is like your choice based when you configure these things. Next question. The EulerSwap contracts repository does not natively include parameters, tuning library for concentration and fees, right? Correct. Yeah, it's not in the contract itself. What I want to do is open up a little JavaScript library that I've been building to make this UI, and it would actually allow you to do some things like compute the price parameters. Concentration is actually relatively simple because it is just the 0 to 1 number that's scaled 18 decimal places. But there are definitely some utilities that would help. Let me get that to you guys as soon as I can. Yeah, another point from Lumo is that this Desmos calculator. I think this is Michael's explainer for the EulerSwap curve is also really cool. Next question, equilibrium params, is it fixed or flexible? Depends on the market price. So on any one given instance of EulerSwap, it is fixed, right? All of these things except for current reserve are fixed, right? These are like immutable parameters of the pool. The current reserves will actually fluctuate as market, as like swaps happen, right? That's why they're current, right? So if you did want to change any of the equilibrium parameters, like the reserves there, or the price of equilibrium, or concentrations or fees, then you have to uninstall and reinstall with a new one, right? My edit UI actually works here because it can atomically do that for you, right? It can change, you get the old parameters, load them into the UI, and then when you hit install, it atomically uninstalls the old one, installs the new one, right? And the contracts have been designed such that you can easily do that without any disturbance to the pool, right? Yeah. So I think unless there's any more questions on configuration and scripts or like how you would do this, why don't I quickly jump over to the code, and we can have some questions there, no doubt. So yeah, this is the EulerSwap repository. It's a pretty typical Foundry project or Forge project. There's a source directory and the Foundry toml, and you'll just have to like Forge install basically to get it working. The main entry point to talk about is probably the factory, right? This is the one that you would probably integrate with the first if you're doing some kind of like integration that creates EulerSwap instances or looks for existing ones or anything like that. So what this essentially does is, expose this function deploy pool, right? And you give it the parameters of the curve. Those are like the immutable curve parameters, like the equilibrium, price, and reserves, and fees, and concentrations. And you also get the initial state, which is just the current reserves, right? And like Ken was asking, is sometimes those will be the same as equilibrium reserves, and that's probably the typical case, but not always, right? There's some use cases for having them separate. And finally, it takes a salt, right? And the salt, to explain the reason for the salt, I just need to quickly go into how it actually works for deploying. It uses this meta proxy deployer thing so that it's relatively cheap to deploy each particular instance of the pool, right? But salt will just get passed through to the create to opcode more or less, and controls the output address, right? And now a little bit of an annoying thing is that we have this integration with Uniswap 4, which is really cool, by the way, the Uniswap hooks. But the sort of annoying thing is that a requirement of Uniswap 4 is that the address it follows a particular pattern that matches like which operations are hooked. So you have to kind of, when you create a pool, you have to mine it. You have to like try a bunch of salts until you find the one that matches the right address, right? So that's a little bit annoying. But my JavaScript library will have that too. There's how to do that. It's not difficult. It's just a little bit annoying. So anyway, you call this function deploy pool, and it returns you the pool's address, right? The one tricky thing is that you need to first install this as an operator, right? It'll actually check that you have installed it as an operator. And that means that you have to actually install the address before you as an EVC operator before you create it, right? Which sounds paradoxical, but is actually just fine, because remember we use the create to deterministic construction, so you'll know the address, right? You compute the address off chain and then install it as an operator and then create it, and it appears at that address, right? And you can do it all in one EVC badge. But anyway, after you call this, bang, you've got a pool. You can uninstall it because any one in particular account can have at most one operator installed, per factory. So all you have to do is call uninstall if you want to get rid of it. And then there's some utilities like for computing the pool address and like reading the currently existing pools, right? You can get all the pools that have ever been created with this, or you can take slices, or you can like get pools for a particular pair, right? Like if you only want the USDC USDT pools, call this one pools by pair. And yeah, the rest is all just utilities. And I think that's all to say on the factory, really. The periphery is a very simple contract that it pretty much just exists to provide like a convenient way to actually perform swaps on these things. Because just like most of the Uniswap designs, you can't really use it by itself, at least not safely. Right? You need sort of this periphery contract to safely handle approvals and stuff like this. So that's what this does, right? And it also, has some convenience functions for quoting. But other than that, like this is just a totally optional contract that you don't even really need. You don't need it for configuring. You don't need it if you're integrating swaps. Like if you're an aggregator, you would probably have your own configurator wrapper contract, right? After that, the interesting bits are EulerSwap. It's this Solidity file itself and some stuff in the libraries directory, right? There's a couple like minor utilities, but they're not what we're talking about right now. EulerSwap is what implements the actual operator flow itself, right? First of all, there's an activate. This is kind of like the constructor, but remember that I said that each pool is actually a proxy instance, so it can't be run in a constructor. It has to be called by the factory afterwards, this activate method. It does some some basic parameter validation and installs the current reserves that you set. And here's the kind of tricky bit, is it verifies that those current reserves you provided are on the curve that you specified with your parameters, right? So if you just make current reserves equal to equilibrium reserves, you don't have to worry about that. It always is. But if you're doing that weird thing where you have them separate, you need to calculate them. And there was a discussion in Discord about that, about how to do that. In the Encode Discord. Again, my library will have that too. But the easiest thing, just set them equal. Don't worry about it. Next, it does some approvals and enables as collateral, so it actually can do the leverage. And then there's some getters, quoting stuff, et cetera, et cetera. Here's the real function of the whole thing, right? This is swap. And what this says is basically, I'm a swapper. Give me this amount of 0 out and this amount 1 out, and then I will make sure I provide you the necessary input, right? And optionally, there is this callback that you can execute, right? Now, to provide the input, I actually send it to this contract, right? So the simple way to do it is to just take your input tokens and send it to the contract, and then call swap, and it'll give you the output ones and take what you sent in, and then check everything is fine. And assuming it is, then it succeeds. However, there's a pretty advanced flow where, like a little bit advanced flow called flash swaps, which I think is like pioneered by Uniswap 2, or one of the earlier implementations, which basically is the reason why we have this function defined like this. Is it's API compatible or nearly API compatible with Uniswap 2, right? So everyone's very familiar with it. And the reason why you would want to do these sort of flash swaps, like you want an interface like this, is that you might actually take the amount out first and then have a callback invoked and then go get the input, right? So you can actually take your output first, do whatever you need to do to get the input, and then give the input, right? So it's quite flexible like that. What this function does is it just first sends the caller whatever they want. They could take all the tokens of the pool if they want, of both of the assets if they wanted to, right? And then it invokes the callback from the caller if it's provided. And then next, it takes a look at all of the assets that have been sent to it, like the EulerSwap instance, and deposits them on behalf of the user, right? And then finally, at the end, it calls this verify and makes sure that everything matches up. We're still on or above the curve, right? So yes, you can take out all the tokens you want, but you have to put in enough to keep the constraint, the actual curve constraint valid, right? And then finally, we just made a swap. There's really not too much more to say on this. There's another alternate entry point in the Uniswap file because they actually use these before swap hooks. Yeah, I'm not the best person to explain the integration of the Uniswap stuff. We had a few people from the Uniswap Foundation, like Sauce, working on this. But the high level description is that this is another alternate entry point to the swapping, right? Instead of calling the swap method, the the Uniswap 4 system will invoke the before swap hook. And like instead of using their sort of liquidity built in, it uses it fakes the liquidity basically, and instead uses the EulerSwap reserves logic, right? But at the end of the day, you can see it's pretty much the same. Magic stuff happens about taking stuff from the pool manager, putting it back in the pool manager, etc. But at the end of the day, we still just verify that it matches the curve constraint. So it's really just an alternate entry point to the swapping. Next, the libraries are a little bit interesting. This is mostly just related to the proxy magic we use because we wanted to keep it relatively cheap to create EulerSwap instances. So this is kind of a similar trick we used in Euler vaults, if you're familiar with it. Fundslib is kind of like the low-level mechanics of how funds are moved around, more or less, right? So it has like approvals and what you have to do to withdraw from a vault. By the way, this is kind of a weird name. It's actually like withdraw, and then if there's not enough left to withdraw, borrow. And deposit is the opposite, right? Like deposit first repay any debt if it's there, otherwise deposit, right? So there's some like subtleties there about enabling controllers and stuff, but that's basically it. It's just the low-level moving funds around. Couple questions in the chat. Any access to the recordings? Let's follow up in Discord about that. There will be. Second question, can one pass custom callback data to the swap functions or custom logics? Yes, you can. So for example, if I go back to the swap function, you can pass the data here, and that is it is passed to the EulerSwap call, like when you invoke the to address, it's provided, right? So you can use that instead of, for example, using storage if you wanted to chain stuff like that. And yes, the swap function is the only way to do that with external contracts. I don't believe it's possible via the hook method, if that's what you're referring to. Yeah. Yes. Question if there's an SDK or you have to interact with the contracts directly. Well, so there are some test utilities and things in the EulerSwap repo if you're interacting with from Solidity, but we're going to have a JavaScript SDK too. That'll help quite a bit. I think I'm running a little bit low on time, so let's just breeze through these other libraries because they're pretty important too. QuoteLib, this is the thing that actually is invoked to figure out how much you can swap, more or less, right? So the meat of it is all figuring out if there are any other constraints that would prevent a swap from happening, like supply caps, borrow caps, the amount of cash available in the vault, and so on. And it also does like some basic curve calculations for this too, right? The find curve point method. And that is all in the real core, the heart of the system in CurveLib. And this actually implements that verify function, that important function we were talking about that makes sure that that makes sure that the state of the pool is consistent and no funds have been taken out that shouldn't have been. And then here's the special F function, which if you read the white paper is like the mathematical definition of the curve, right? It's kind of like each half of the curve has its own F, right? Its own parameters, more or less, right? And then we also have this F inverse. That's needed for quoting. But not for verifying the invariant. And I think that covers everything. Yeah. So it's not, they're not huge contracts, but quite a bit of work and we've done quite a few iterations on this to bring it where it is. And honestly, we have a few other things that we want to improve on in EulerSwap 1.1 we're working on. It won't change very much, especially from the perspective of your project. So anything that any of you do will certainly port fine to the next version we do. And I think that's it. Any questions on the code or configuration? Anything?
Hey, Doug. I saw that chat has been very active, and I think most questions has been covered during the workshop. everybody, like if your question has not been covered yet, please like use this chance to ask final questions to Doug, so you have chance to get answer directly. While just like ask a question. By the way, everyone, if you miss this time, also like at Discord server, you can ask questions. So you can see there like a left bottom corner. You see the join Encode Discord. If you join, you can allocate to the like a Euler Builder competition role. There you can ask questions to Euler team directly as well. Also, recording going to be uploaded tomorrow. I just shared the first recording from Michael, and then the workshop today with the Doc going to be uploaded tomorrow, and we're going to share the links on the Discord server, and also you will get the weekly updates as well. Otherwise, Doc, there's another question from Conf, and I can see that also Marcelo is typing in.
Excellent. Yeah. Right. So good question. So first question is, due to the price XY limit, is there any like price X over price Y limit? Is there any practical token you cannot use? So yeah, so the prices are expressed as a fraction, right? That's why the price X and price Y are kind of like numerator and denominator in the fraction. And it needs to have a very large dynamic range, because I guess what you're getting at is decimals, tokens can have widely differing decimals, right? And the price actually encapsulate the decimals too, right? And this is one of the reasons why, for example, in EulerSwap 3, for price representation, they use a logarithm-based encoding, right? The tick encoding that they use, right? And that gives them a huge freedom in the number of like decimals. You can easily price like, I don't know, like a 20 decimal place token against a 2 decimal place token, right? With this fraction, we do have some limitations, just purely because we're not using a logarithm-based encoding. It's just a direct fraction. But we back at the envelope did, and there shouldn't be any practical tokens that are affected by the limit, affected by the limits. You can easily price like a 6 decimal place tokens versus 18 decimal place tokens, even if there's like $1 million disparities and stuff. I think like the very, very worst case one we could think of was like wrap Bitcoin versus Pepe token or something like this. And even that, it's still valid, right? So, there's not too much more room, but I think it should, be fine. And yeah, the other thing is that the precision of the price fraction doesn't necessarily need to go to like 10 decimal places of price either, right? Because the equilibrium point is, first of all, market pricing is not that granular, and also the equilibrium point is a little bit arbitrary. Next question, yeah. So follow up, or next question is, do you have gas benchmarks against Uni 2 or V3? This is a little bit complicated because there are many different possible operations that a swap can perform under the hood, right? Some of them might do borrows and repays. Some of them might just transfer funds from one vault to another, right? So there's quite a bit big range, but in general, like typical swaps, I would say are about twice as expensive as Uniswap 3. Like it's roughly in that order. I think it's I think 350K gas in the best case, and like 650K in the worst case, something like this. So not amazing, but still not, especially for larger swaps where it can amortize that gas cost, not doesn't totally take out of competition or anything. And then on L2s, of course, the gas prices are less significant. Next question from Juan. Looks like this only enables just-in-time liquidity. Can traders see an estimate of the available liquidity for their trades? So traders themselves don't need to care necessarily about whether the liquidity is like just in time or is actually there. Because yes, the coding methods will look and see if the liquidity is there, right? I can probably disconnect this one and just quickly go back to the other window. So for example, like quoters, traders would be looking, probably not at this view, but like some aggregator or Uniswap interface or something that encapsulates it. But they would basically see this, right? This amount is available for taking out of USDT, and this amount is available for taking out of USDC, right? So if I wanted to swap some amount to get 50,000 USDC, I could do it, right? doesn't the price might not be great, which is, that means I actually need to fetch the quote, but it's doable because the rough limits. So yeah, like just to recap, the traders don't necessarily care about the liquidity, or like they just get their order fulfilled, and then the liquidity is transferred, and in that case would be visible here, right? So like on I mean, if I go back to my portfolio, we would see that oh yeah, by the way, price impact came back 0.2%. So in this case, it would like leverage or deleverage one of these trades, right? And that would be the effect of the just-in-time liquidity. Oh, sorry, I missed the second part. So I'm asking because I've read that the absence of passive liquidity provision can discourage traders from trading, especially if they have no way to impact the price impact to the lack of visible liquidity. Right, I see what you mean. Yeah, like there's this notion of like, you know, dark pools, for example, and like obfuscation of market depth and things like that. I would say that EulerSwap has the exact same properties as Uniswap 2 or 3 in this case, right? If the liquidity is available like in simulation, it will be available in execution. There's not really any the JIT doesn't have any special influence on that, other than the fact that I guess maybe sometimes multiple pools can be sharing the same like virtual liquidity, and it wouldn't actually be there if you executed both of these orders. But like that would be manifest if you like that would be handled if you traded one totally, then the other one would go away and you would see its liquidity disappear immediately, right? So I guess it might have some impacts over like aggregated trades, but you would still see that in simulation. So I'd say it's roughly the same model as Uniswap 2 and 3. Everything is public on chain, and the just-in-time liquidity is like sort of reserved in at least in the scope of a simulation. Next question, is EulerSwap already included in Euler? I always get confused with names. For example, I had the same trouble with Morpho and then Morpho Blue, and yeah. I know what you mean. It is partially included. So the contracts are actually deployed and we're using them. And like I said, EulerSwap isn't even really like a separate product, I guess. It's kind of like just using the features we have available already in Euler. Like I was saying, is that, you know, we didn't have to build an EulerSwap console to go see your positions. We already have the UI, right? I'm looking at it here, right? We're going to, and this is why I said it's partially included, because this doesn't actually show you right now that there's an EulerSwap operator installed in this account, right? Which would be a pretty important thing to see, right? And also a way to uninstall it and reconfigure it and stuff. So we're working on that, and that'll get rolled out soon enough. But it's already available and technically usable if you were, you know, technically inclined to install these things and manage them yourselves. But it's not going to be like an entirely separate product, I guess, to the extent of like you say, like a Metamorpho on top of Morpho or whatever, right? Good question. Yeah. And then yeah, the following up is where to look for the code base. Yeah, that's just in our EulerSwap repo. Yeah, so all the code for EulerSwap is in Euler-swap repo on our GitHub. Yeah, that's where the current code base is. And you sort of, to understand it, you might need to go look at the EVC, that's the Ethereum Vault Connector, and the EVK, that's Euler Vault Kit repositories as well. But all the EulerSwap specific stuff is in the EulerSwap repo. Next question from Giovanni is, as far as I understand, the entire current reserves will look like available liquidity for trades. And if they're routed through solvers and routers, the trade will be routed through multiples trying to get the best price for them. Yeah, that's basically correct. So the current reserves are like the theoretical amount that you could take out of this EulerSwap instance, right? The only slight complication and is that in some cases that current reserves might not be totally fillable, right? Because you know, for example, the vault that you're supposed to withdraw from has been totally borrowed out, right? Like it has zero cash available. In that case, like the effective current reserves have gone to zero, right? And that's why if you look in the code base, we have this function called get limits. And also like this is what quoting uses under the hood, right? This is why quoting, this is all transparent to quoting. And those, if the vault was borrowed out, the current effective current reserves visible to the quoter would be 0, and you wouldn't get a quote from that pool, right? So that's why current reserves are not the best place to look for that. It's better to actually get quoting yourself, like get quoting for the size you want, or use get limits, right? But yeah, like exactly right. This is sort of a problem for the aggregators, right? They have to be able to figure out, given all these different pools, check out their price impacts and quotes and fees and all this stuff. And if the pools have been utilized, like the underlying vaults are fully utilized, I can't use that one. That's all kind of responsibility of the aggregators. And we've given them the tools, like especially get limits and quoting in simulation. So that's how we expect it to work. Next question. My understanding is that a pool's liquidity supply is governed by a single Euler account, which, although it can have multiple operators, is still essentially one source of funds. Correct. How does this affect large trades when the Euler account cannot fulfill them, either due to insufficient collateral or an inadequate balance in the vaults? So if the Euler account can't fulfill them, like for example, if you configured the curve like sort of incorrectly, and it went beyond this white bar, for example, which my configure action will stop you. It'll stop you from dragging the curve that far. But there are cases where it could get too far. For example, you have paid a lot more interest or whatever, and it's actually pushed you out there, or the governor of the vaults have changed the LTVs or something like that. So in that case, you could be beyond, your curve could extend beyond this. And then if somebody tried to do that swap, that would actually fail, right? The EVK would actually prevent that from happening because you would be in violation, right? In that case, yeah, like the experience for the swapper was not great. They would get like a weird error in simulation as opposed to, and the quoted value that they got would be not right. But it wouldn't actually threaten the security of the system or anything, right? And you can never like directly be put into like a liquidatable position due to this, because we almost always have these little LTV buffers, right? So the worst case is that you would go directly up to the borrow LTV, but there's still a bit of a gap between that and the liquidation LTV, right? And I guess the follow-up question is there any way to plug in liquidity from other providers? Not directly, but notice that one thing I didn't expand on in here is that you usually have 2 vaults, right, in an EulerSwap, but you can actually have more vaults set up as like side collateral too, right? So you could do a USDC WETH, but also have a USDT in there to collateralize the position further, right? And I'm still working on the UI to actually represent that like extra like side nav that you have and push out those white bars even further. But not directly, if I understand your question, like the funds always have to be inside your Euler account, like deposited into a vault on behalf of your Euler account. You're welcome. Yeah, anything else for anyone?
Thank you very much, Doug. That was a really good Q&A, and thank you everyone in the meeting as well for all the questions that you've asked. It's really, really good to see an active chat. So I think that we might end the session there. And if anyone has any questions, please feel free to ping both the Encode team and the Euler team as well. And yeah, thank you very much. That was a really good workshop.
Thanks, everyone. See you later.
Bye.